Hello there, Professor. My name is Owen Beattie, student number 101379668, and this will be my video submission for my research assignment in our Boundaries of Science course. I've gone ahead and selected the topic Dark Matter, so I've titled it What's the Matter? Dark Matter, and let me jump right into it. So here's my table of contents. I will cover the history of dark matter, why we conceptualized it, and why we believe it exists. Then I will cover two of the leading theories as to what dark matter may be, and then I will have a conclusion and my own personal thoughts on the topic. So first of all, the opening and history. So the conceptualization of dark matter. Dark matter, the term, was coined by a scientist, Fritz Zwicky, in 1933, when he was observing the Coma galaxy cluster. The galaxy cluster was moving too quickly for all of the galaxies based on their predetermined mass, the mass that we had studied and assumed that it had. It was moving far too quickly for that amount of mass. So he assumed that there must be a reason. So we began looking into dark matter. So for our first understanding of dark matter, let me give some more background on the topic. Visible matter is comprised of baryons. That is a generalized, overarching term for protons, neutrons, and electrons, everything that we can interact with. And from what we've discovered, based on Zwicky's research, baryons only contribute to 20% of the mass in the universe. That leaves an astounding 80% of matter which is non-baryonic or dark matter. And currently, we have no definitive way to detect dark matter. We can't see it, we can't feel it, we can't touch it, can't hear it, nothing like that. And none of our scientific equipment is capable of picking up on it either. So, therefore, we have to theorize as to the nature of it. And our first theory are WIMPs, a pretty accurate name. This is our first and one of our leading theories as to what dark matter is. It stands for a weakly interacting massive particles. It is they are a type of neutrino, which are a very small and undetectable atom. They are thought to have a very, very minuscule mass. But they are incredibly abundant, with up to 100,000 passing through each square centimeter of space at any given time. So everywhere around us, even through solid matter, everywhere in space, hundreds of thousands of these WIMPs may be passing through and shooting through everywhere, which is a very interesting way to view the universe. That would imply that there's so much happening around us and we would have absolutely no idea, which honestly is in keeping with stuff or forces like gravity and electricity. So that would be very, very interesting to discover. And our second theory that I'll be covering is machos, which I would consider even more accurate than WIMPs and are really the opposite side of the theory. They stand for massive astrophysical compact halo objects and are basically the opposite of WIMPs. They're hypothesized to have an incredible amount of mass. They're comprised of things like neutron stars and brown dwarfs and white dwarfs, types of stars and celestial bodies that have incredibly high density for their general size. So they would be something like the size of Jupiter, or perhaps even smaller, but be incredibly dense, and they would, in theory, hold galaxies together, like the Coma cluster. They would be small, dense, and dim, which contribute to our difficulty in discovering them and finding them, but also It is possible that due to how dense they are, similar to black holes, they could be bending the light which would otherwise reflect off of them. And that, in conglomeration with them being small and dim, it could make them very, very difficult for us to discover, simply because of how dense they are. So, now jumping into my conclusion, I find WIMPs and machos both very, very interesting. I think that the idea that hundreds of thousands of these tiny particles are shooting around us at all the time that's very, very interesting. But also, on the other hand, machos are very interesting because they're these relatively small things that are so dense that there's no way for us to see them in theory. I like both of the I like both of those concepts and some of the other less notable theories that I found in my research. Personally, I would be kind of more optimistic and slightly less scientific in my thinking, but it would be incredibly exciting if they were perhaps another force of nature, something like gravity or electricity, which had always been flowing around us in the past, but we had never discovered how to use them. Like our old, very, very, very ancient ancestors who had literally no idea about electricity, but may have received static shocks. And then eventually we discovered how to harness it, and electricity now allows me to make this presentation and connect over the internet. So it would be incredibly interesting, and I would really, it would be so cool if dark matter was just another force of nature that we just haven't discovered and we may be able to harness someday. Either way, this research assignment has been a fantastic jumping off point for my continued research into topics like this. I've been interested in science for a very long time, and that's why I took this elective. But either way, this has been a fantastic way to jump off into more research on this topic. So I'd just like to thank you for watching, and here's my bibliography, and I hope you have a great day.